This video is going to go over the Unit 4, Topic 2, Formative 3 review. So it's really important that to prepare for your test, you understand everything that goes on in this video. So my advice would be to print out an extra copy, try this, and then come back to the video and watch the parts to see where you don't understand and try to follow along with what I'm doing and learn from that to prepare for your test. So Jason wanted to see how far and how high he could punt a football. The variable x will represent the horizontal distance the ball travels, and the variable y will represent the height the football will reach. The path of Jason's football traveled along the parabola, represented by the quadratic equation, is y equals negative x squared plus 12x. So we're going to use that equation to help us put it in factored form and vertex form. So if you notice, what form is this already given in? And hopefully you are saying to yourself, standard form, because that would be the right answer. So we're looking on how to change from standard to factored and standard to vertex. Let's first look at how to go from standard to factored form. So this is going to be about factored form. One thing I have been trying to emphasize in all my videos is if your leading coefficient ever has a negative in it, you need to pull that negative out because you really want to look at the quadratic when the quadratic term is positive. That's what we know how to do. That's what we've been working on. So I'm going to take my equation, y equals negative x squared plus 12x, and I'm going to pull out a negative because I don't want you working with that. What we have left over is this binomial, but I need to divide each term by negative because that's what we put on the outside. So negative x squared divided by negative is x squared, and 12x divided by negative is negative 12x. I want you doing this anytime you see a negative attached to the quadratic term, so attached to this leading coefficient. Now I'm going to look at how do I factor x squared minus 12x. So I'm just going to look at this separately from the negative. There's a couple different ways to do this. Some people like to say, oh, well, this is x squared minus 12x plus 0. So what multiplies to 0 but adds to negative 12? Well, we know that one of the numbers has to be 0, and if it's going to add to negative 12, the other number has to be negative 12. So what I'm going to get is x plus 0 and x minus 12. Another way to look at this is if I see x squared minus 12x, I want you always looking to see if there's a GCF, a greatest common factor, and if there is, you want to pull it out. So I notice that x squared and negative 12x both have an x. So I can take that out, and again, I'm going to then divide each term by x. So x squared divided by x is x, and negative 12x divided by x is negative 12. So either way, I'm going to have one of these two answers as my factored form for this. But remember, our final answer has to include this negative in front. So I can have y equals negative x times x minus 12 because I'm just replacing what's in here with what I factored. I could also have y equals negative x plus 0 times x minus 12. I don't care which answer you keep, but you need to have one of them. You always want the negative on the outside. Don't redistribute it back into one of these. You want to leave the negative on the outside. And once we have factored form, we can find some interesting facts like factored form is the best one to find your x-intercepts. And your x-intercepts are when x equals 0 and when x equals 12. Because remember, when we're trying to get y to be 0, remember an x-intercept is when y is 0. When we have y equals 0, either this factor has to equal 0 or this factor equals 0. So what values of x make this 0? 0. What values of x make this 0? 12. So these are our possibilities and these are our x-intercepts. Now we're going to work on changing from standard form to vertex form. Our general equation for vertex form is y equals a times x minus h squared plus k. So if you remember this, one of the things that will clue you in is we're looking to find some side of a square squared, meaning we're looking for a perfect square. I've told you this before, I'm going to tell you again. I don't like that there's a negative in front, so I want you to pull it out. So we have y equals negative x squared minus 12x. We are going to work on completing the square and putting into vertex form this part right here. We're going to deal with the negative at the end. So I have x squared minus 12x, and we can say plus 0. I want to put this into a perfect square. So I know I have x squared, and then I know that I have negative 12x's, which I need to split up evenly. So I'm going to have negative 6x's here, and I'm going to have 3, 4, 5, 6. I'm going to have negative 6x's here. What that's going to give me is a side of x minus 6 and a side of x minus 6, which means that I have a perfect square. We also know to find how many 1's there are, negative 6 times negative 6 is 36. So this square is going to be x squared minus 12x plus 36, which also factors into x minus 6 squared. So I know that my perfect square is going to be x minus 6 squared. However, I need it to equal this one. So I need it to be equal to x squared minus 12x plus 0. Right now I have x squared minus 12x plus 36. So how can I go from plus 36 to plus 0? I can subtract 36. So my actual vertex form is going to be x minus 6 squared minus 36. Now remember, this part here, this vertex form, is what is going inside the parentheses. We still have this negative on the outside, so don't try to jump the gun. So what we have is y equals the negative of, now I'm going to replace x squared minus 12x with my vertex form. So I have x minus 6 squared minus 36. So I'm going to take my negative and I need to distribute it to each term. Now, when we multiply this negative, or negative 1, times x minus 6 squared, remember, I can't go, oh, negative of 1 times x minus 6 squared is actually negative x plus 6 squared. Can't do that because order of operations says we deal with our exponents first and then we multiply it out. So we're just going to leave the negative on the outside, and we're going to have x minus 6 squared. So the negative of x minus 6 squared is negative x minus 6 squared. Then we have the negative of negative 36, and the negative of negative 36 is positive 36. Therefore, this is going to be our vertex form. And what's nice about vertex form is that we can easily see the vertex, which is going to be 6, 36. Because if you remember, h, which is in here, is always the opposite. Looking back at what we have, we've now found our equation in factored form, and we have our equation in vertex form. We're next asked to graph the equation on this grid and complete the table below. If you have your graphing calculator, feel free to put in one of these equations into y equals, and then press second graph, which will then give you a table of values. Feel free to use that if you want. But some of the things, let's say you don't have a graphing calculator, we can find our, for instance, we have our x-intercepts. Our x-intercepts are at 0, again, sorry about my pen, and 12. And then we know we have a vertex at 6, 36. If I wanted to find any more points, I can just plug in numbers. For instance, if I wanted to know 8, I could plug in here, for instance, 8 minus 6 is 2. 2 squared is 4. The negative of 4 is negative 4. So negative 4 plus 36 is 32. So 8's going to be 32. We also know that our parabola is symmetrical. So if I'm going 2 over from 6, I can go 2 back to 4 and get 32 as well. I could also put in 10, let's say. 10 minus 6 is 4. 4 squared is 16. The negative of 16 is negative 16. And negative 16 plus 36 is going to be 20. So at 10, I can go to 20. This also means that at 2, I can go to 20. And that's enough points to make a graph. Sorry about the cleanliness of my parabola, but you get the point. Finally, we need to answer a couple questions. For instance, what's the vertex? Well, looking at the vertex form, remember x has h attached to it, and h is always opposite. We have 6, 36. Looking at factored form, all right, we can see that our x-intercepts are 0 and x equals 12. My line of symmetry is a vertical line that goes through my vertex, so that will be x equals 6. And then finally, domain and range. We're dealing with a real-world problem. So because we're dealing with distance for the goal line, we can't have a negative distance, and our distance stops at 12. For height, we don't go past 36, but we also can't have a negative height, so we have to stop at 0. So my domain is going to be 0 is less than or equal to x, which is less than or equal to 12. It's less than or equal to because 0 and 12 are points that are included. And my range is 0 is less than or equal to y, which is less than or equal to 36. So my domain in the context of the problem goes between my x-intercepts. And my range in the context of this problem goes from my most minimum value, which is 0, to my maximum value, which is the vertex. If we move this down, we see that our next questions are, what do the x-intercepts mean in the context of the problem? To save some time, I'm going to write in the answer, and then it's going to appear for you. So we'll talk about it in a second, but I'm going to pause the video for me, write it in, so it's going to appear what looks like magically. So what do the x-intercepts mean in the context of this problem? Well, the football started at a distance of 0 from the goal line and ended at a distance of 12 from the goal line. So it started at 0, ended at 12, which means that the football traveled a total of 12 yards. The x-intercepts give us the starting and ending point of where the ball was on the ground at a height of 0. Explain what the vertex tells us about the problem. Well, the vertex is the point at which the parabola stops increasing and it starts decreasing. So the vertex tells us how far away from the goal line the football was when it reached its maximum height. So it tells us what our maximum height is, which was 36 yards. So for question number 5, what does the line of symmetry represent? The line of symmetry represents the midway point of the football's trajectory. That just means the football's path. At the line of symmetry, it's going to be at halfway. So it has reached its maximum height at 6 yards from the goal line. The line of symmetry says this is the point at which it's going to stop increasing and it's going to start decreasing. So it also tells us that the football is increasing in height from 0 is less than x to less than 6, and it's decreasing from 6 is less than x to less than 12. So then Marco saw Jason punt his football and wanted to see how far and how high he could punt a football. The variable x will represent the horizontal distance the ball travels, and the variable y will represent the height the football will reach. The path of Marco's football traveled along the parabola represented by this table. So we're given a table, and I do apologize, this should not be Luis's punt. It should be Marco's punt. So we're given a table of values, we're not given an equation, and we need to write it in standard form and factored form. I'm going to show you that I think one of the easier ways is to, given a table, to put it into vertex form, and then from vertex form you can find standard form and factored form. But don't be limited to this. If you want to graph the equation, find the intercepts, and put it in factored form, that's fine. I'm just trying to do this as a review, so at least I can also show you how to put it in vertex form, if you need that. So one of the things that we can notice is that our y values are going up, 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 and then they go back down, which tells us that 516 is going to be the vertex. Now I'm going to go onto a new slide, and I'm going to talk about how to put this in the vertex form, and then we're going to come back to this. So from the previous slide, we saw that the vertex was going to be at 516. And our general form for vertex is y equals a times x minus h squared plus k. So what we could see was that our x value would be coming into our h, remember that it's always the opposite, and our y value would be k. So plugging those in, we see that we have y equals a times x minus 5 squared plus 16. The only problem is that we still don't know what a is. Now, if you're able to look at the table and figure out what a is, that's fine, but what I'm about to show you is a foolproof method that works every time. So I recommend that you get comfortable with this, just in case. If I look back at my table, I can pick any point. I advise you never to pick the x-intercepts, but I can pick any point to plug in to my equation. So I'm going to plug in the point 2, 7. It doesn't matter which point you pick as long as you know that it's on the graph. My y value is 7, so I'm going to plug that in for y. I still don't know a, and my x value is 2, so I'm going to plug that in for x. And I'm going to have 2 minus 5 squared plus 16. Well, I want to solve for a, so I need to get rid of my 16 first. So I'm going to subtract 16 on both sides. What we have is 7 minus 16, which is negative 9, equals a times 2 minus 5 is negative 3 squared. Well, I have negative 9 equals a times 9, or we can also write this as negative 9 equals 9a. And then I'm going to solve for a by dividing by 9. And what I get is that a equals negative 1. So once I know that, I can plug it back in, and I'm going to get my final answer for vertex form as y equals negative x minus 5 squared plus 16. One nice thing to note is that once you've found a is going to be the same no matter what, so you don't need to find a repeatedly. So looking back at this, I need to find standard form and factored form. I found vertex form, so I can multiply this out and put it into standard form. So I have y equals negative, and then I have x minus 5 squared, which is really x minus 5 times x minus 5. And then I have plus 16. I'm going to take x minus 5 and multiply it by itself. If what you're comfortable with is a box, that's fine. You know, you're multiplying x and negative 5 and x and negative 5. And x times x is x squared. We have negative 5x, and 25. So what this is going to simplify into is the negative of x squared minus 10x plus 25 plus 16. We then need to distribute the negative, So we have y equals negative x squared positive 10x, because I'm multiplying the negative out, and negative 25 plus 16. So my final answer is going to be y equals negative x squared plus 10x, and then I have negative 25 plus 16, which is going to be minus 9. So that is my standard form. Now to find my factored form, I'm going to use my standard form to help me. If you notice, the leading coefficient starts with a negative, and we don't like that. So the first thing we want to do is pull out the negative. Then it means I'm going to divide each term by the negative. So negative x squared divided by negative is x squared. 10x divided by negative 1 is negative 10x. And negative 9 divided by negative is positive 9. I'm now going to focus on factoring what's inside the parentheses. So what multiplies to 9 but adds to negative 10? Hopefully you're saying negative 1 and negative 9. And so I get my final answer of y equals, I'm going to keep the negative on the outside and I'm going to factor what's on the inside, which is x minus 1 and x minus 9. This is going to tell us our x-intercepts, 1 and 9. Vertex form tells us our vertex. And yeah. So next we're going to look at the equation on a graph, and we're going to see what happens to the vertex, the x-intercepts, the line of symmetry, etc. So to graph this function, we've got our table of values, so I would just focus on that. When x is 1, y is 0. When x is 2, y is 7. When x is 3, y is 12. When x is 4, y is 15. When x is 5, y is 16. When x is 6, y is 15, and it's going to keep dropping back because parabolas are symmetrical. So at 7, it's going to be 12. At 8, it's going to be 7. And at 9, it's going to be 0. And that really fits in with what we found in our factored form, because we saw that our x-intercepts were going to be 1 and 9, and our vertex was at 5, 16. So we have our vertex of 5, 16. We have our x-intercepts of x equals 1 and x equals 9. We have a line of symmetry of x equals 5. Now we have a domain. Remember that this is in context of our problem, so all values of x between 1 and 9, and our range is going to be all values of y between 0 and 16, because our x-intercepts deal, our domain deals with our x-intercepts, and our range deals with the y value of our vertex. Next we have to answer the questions. What do the x-intercepts mean, the vertex, line of symmetry, and then our cumulative question about who kicked the ball higher and who kicked it further. So what do the x-intercepts mean? This is the same thing as the last type of question, so I'm going to go through this quickly. But the football was punted 1 yard from the goal line and landed on the ground 9 yards away from the goal line, so the football traveled a total of 8 yards. At 5:16, which is where the vertex is, this means that at 5 yards from the goal line, the football reaches a maximum height of 16 yards. The line of symmetry, it represents the midway point of the football's trajectory, which is the football's path. So it's reached its maximum height at 5 yards from the goal line. So line of symmetry tells us where the football reaches its maximum height. It also tells us the football's height is increasing from 1 to 5 yards and decreasing from 5 to 9 yards. So who kicked the ball higher, Jason or Marco? So we can tell Jason kicked the ball higher because Jason's vertex is higher up than Marco's. So Jason kicked the football and it reached 36 yards, while Marco's only reached 16 yards. This was found using the y value of the vertex. Then we are asked who kicked it farther. We're going to use the x-intercepts to help us say that, because Jason kicked the ball farther. The X-intercepts tell us that he kicked a total of 12 yards. He started at 0 and the ball landed 12 yards away from the goal line. Marco started at 1 and it landed at 9. So he only kicked it 8 yards total. If you have any questions on this, you can email me. Next we have Saren. And Saren saw the fun on the football field and wanted to give it a try as well. The variable x will represent the horizontal distance from the ball travels, and the variable y will represent the height the football will reach. So we have this graph of Saren's punt. And a couple things to note. I can see that my vertex is at 736, so 7 comma 36. This is my vertex. And I also can see that my x-intercepts are at 1, and I have an x-intercept at 13. So I'm being asked to find standard form, factored form, and vertex form. And I think the easiest way to do this is find vertex form or factored form first. So let's start with vertex form. We know the general equation is y equals a times x minus h squared plus k. And remember, we know that our vertex, it's 736, so a and then x minus 7, because it's the opposite, squared plus 36. So now all I need to do is find a. I can pick any point on the graph, so I'm going to pick, 211. It doesn't matter. I'm going to plug that in, so I have 11 equals a times 2 minus 7 squared plus 36. I need to take away my 36, and we have 11 minus 36 is negative 25 equals a times 2 minus 7, which is negative 5 squared. Well, this gives us negative 25 equals, and negative 5 squared is 25, so I'm going to have 25a. Last thing I need to do is divide both sides by 25, and I see that a equals negative 1. So my vertex form is going to be y equals negative x minus 7 squared plus 36. Next, I can find factored form pretty easily. Factored form is of the general form, so this is going to be factored. So of the general form, y equals a times x minus p times x minus q. Remember that everything that deals with x inside the binomial, these are going to be opposites. The other thing that's nice is we already know a because we found it over here. So really my factored form is just going to be y equals negative x minus 1 times x minus 13, because those are my x-intercepts that I found. We take the opposite, and we found a over here as negative 1. So moving up, we have the answer for vertex form. We have the answer for factored form. Now all we need to find is standard form. And the best way to find standard form is to just multiply out factored form. Or vertex form, it doesn't matter, but I think factored form will be less work. So we have y equals negative x minus 1 times x minus 13. I'm going to take care of the negative last, but if you want to take care of it first, that's fine. But I'm going to find what x minus 1 times x minus 13 is. If you want to make your box, you can have x and negative 1 and x and negative 13. This is going to give us x squared, negative 13x, negative x, and negative 1 times negative 13 is positive 13. So I'm really going to have x squared minus 14x plus 13. Finally, I need to distribute the negative, so my final answer is going to be y equals negative x squared positive 14x and negative 13. And that's my standard form. So as you saw on the last slide, we found that factored form was y equals negative x minus 1 times x minus 13. And we found that the vertex form is y equals negative x minus 7 squared plus 36. So we're going to complete the table and find the vertex, the x-intercepts, the line of symmetry, the domain, and the range. So looking at the vertex form, we can see our vertex is going to be 7, 36. Looking at factored form, our x-intercepts are going to be x equals 1 and x equals 13. Our line of symmetry is going to be x equals 7, because that's the x value of the vertex. And then our domain, remember it goes between the x-intercepts, so it's all values of x in between 1 and 13. And our range is all values of y in between 0 and the y value of the vertex, which is 36. Finally, we have to answer the last questions. So again, I'm going to make the answers appear and we'll go over them. So looking at our typical answers, what do the x-intercepts mean in the context of this problem? Well, the football was punted 1 yard away from the goal line and landed on the ground 13 yards away from the goal line. This means that the football traveled a total of 12 yards. What does the vertex tell us? The vertex tells us that at 7 yards from the goal line, the football reaches its maximum height of 36 yards. And finally, what does the line of symmetry represent? The line of symmetry at x equals 7 represents the midway point of the football's trajectory. It has reached its maximum height at 7 yards from the goal line. So the line of symmetry tells us where it's going to hit its highest point. It also tells us where it's increasing and decreasing in height. So it's increasing in height from 1 to 7 yards and decreasing from 7 to 13 yards. Finally, we have our last two questions. Who kicked the ball the highest and how can you tell? Well, if you look back, because we're talking about the height of the ball, we'll be looking at the vertex. And Jason and Saren both kicked the ball the highest because they both kicked a ball that reached 36 yards in the air. I can tell this by looking at the y value of the vertex. Jason and Saren both had the same y value of 36, and it was higher than Marco's, who had a height of 16 yards. And then who kicked the ball the farthest? Well, Jason and Saren both kicked the ball the farthest because they both kicked the ball 12 yards. If you look at their x-intercepts, they both traveled 12 yards. We can see this because even though Saren's ball landed 13 yards away from the goal line, he actually started 1 yard away to begin with. Jason's landed 12 yards away, but he started at the goal line. And then if you look at Marco only kicked the ball a total of 8 yards. So Jason and Saren both kicked the ball the farthest. To prepare for this test, I highly recommend that you just practice. Get comfortable with this. Watch some other videos and practice, practice, practice. Look over this review packet, redo it, and you will be fine. All right. Thanks.